Introducing a Bush League organic chemistry production on epoxies. Epoxides are cyclic ethers in which oxygen is one of the atoms in a three-membered ring. This is the functional group of an epoxide in which an oxygen is bonded to two alkyl groups. Epoxies require a co-reactant known as a hardener in order to undergo a three-step addition reaction which forms a product. The product becomes cross-linked on a molecular level, which maximizes the mechanical and chemical properties of the compound. There are a variety of hardeners used in this reaction. These range from functional derivatives such as amines and anhydrides to hydroxyl molecules such as phenols and thiols. The typical hardener found in the industry are in the form of amines. More specifically, amides are often used as the co-reactant to the epoxide resin. The three-membered ring is susceptible to ring opening reactions due to the ring strain and partial negative charge of the oxygen. The hardener amide and epoxy ring form bonds from the nitrogen of the hardener to the alkyl groups of the epoxy. The compound stabilizes and forms a repeating unit that cross-links to form a high molecular weight chain. The product is dependent upon the stoichiometric ratio of epoxy to hardener that can alter the cure time. The molecular weight of the epoxy requires a specific hardener to allow it to cure properly. If this ratio is incorrect, the exothermic release could be very extreme or non-existent where the epoxy and hardener would not bond. When done correctly, two reactants are mixed to undergo a change from their initial liquid states into one gel substance with rubber-like properties during its initial cure stage. Once this occurs, the substance becomes hot due to the exergonic properties that release energy and fuel a release of heat. This makes this an exothermic reaction. As the substance cools, it becomes more solidified and ultimately reaches a solid state in its final cure stage. At this point, the epoxy mixture is generally at approximately 90% of its overall strength properties. After some more time to finish curing, the result is a highly adhesive product that has good mechanical properties, including flexural strength, tensile strength, shear strength, and peel strength. In addition, the product has good temperature and water resistance, which leads to a wide variety of usage opportunities. In order to get the best results, the resin mixture must be applied before it reaches the solid stage of curing, so that it can be spread onto the applied surface where it can then solidify and have use.